Good morning, guys. How are you? I hope all of you are well. For today, we are still in chapter 2. We will introduce probability and we're going to talk about how can we find probability of a certain event. Mainly, we're going to talk about a formula for probability, then we're going to talk about some rules. After that, we're going to be presenting some examples and some exercises. So here we are defining the probability of an event as the sum of weights of all sample points in A. What we mean by it, it means that it's the chance that a certain event occurs. For example, if we are talking about that we have two coins, now you know that each coin, if we want to toss it, we're gonna get either tail or we're gonna get head, right? So if this is coin 1, we're gonna get in it either tail or head. In coin 2, we're gonna get also either tail or head. So if in the first one we got tail, coin 1, in coin 2 we may get tail or head. Also, if in coin 1 we got head, for coin 2 we may get tail or head. So the sample space here as it is TT, TH, HT, and HH. Now, if we are saying that the event A is when in the both tossing we get the same shape, it means that it is tail and what? And head, because we need both of them to have the same shape. So guys, this is an event. This is the whole sample space. Of course, we have here TH. We have also HT. And what do we have also? Finally, we have HH. So if you look here, the sample space, it contains how many elements? It contains 4 elements or 4 sample points. And the event A, it contains 2 points. When we say probability of A, it means that what's the chance that A occurs? So what will be the chance of it for A to be occurring? Either we're gonna get tail, or we're gonna get what, guys? Or we're gonna get head. So how many possibilities do we have? We have 2 possibilities. Out of how many possibilities? Out of 4 possibilities. So we're gonna get P of A equal to what? To half. How can we interpret this one? It means that the chance for when we're tossing the coin, 2 coins, to get exactly the same tail or head, the chance of it to occur is 50%. This is what we mean by probability. And if you look here, we cannot say that the chance for something to occur is 150%. So always the chance to occur should be a value between 0 and 1. When we say that the chance to occur is 0, it means that as if this one doesn't occur. And when we say that the chance to occur of something is 1, it means that always it's occurring. So guys, P of A, it should be always between 0 and 1. It cannot be negative and it cannot be greater than 1. Also, if we are saying probability of the sample space, it will be for sure, it will be 1. Okay, guys, here we have an example. We are saying that a die, you know what do we mean by die? Die, it means that it has 6 faces. These 6 faces, when we say a fair die, or we are not mentioning, it means that all the faces have the same chance to occur. So we are saying that a die is loaded in such a way that an even number is twice as likely to occur as an odd number. What do we mean by this one? It means that this die, it doesn't have, not all its numbers have the same chance to occur. Why? Because we are saying that if we have an even number, then the probability of it, it's twice than that of an odd number. We know that in a die, what do we have, guys? The sample space, it's 1, 2, because here we have only one die, 3, 4, 5, and 6, right? What do we mean by even number? Even number, it means that it's a multiple of 2. And it should be in as. So what are the options here? 2, 4, and 6. Okay, and we are saying that an odd number, it means that it's not a multiple of 2. So 1, 3, and 5. Okay, guys. Let's continue. We are saying here that E is the event that a number less than 4 occurs. Less than 4, it means that it can be 1, 2, 3. We need to find P of E. Okay, guys. We know that our sample space is 1, 2, 3, 4, 5, 6. We just wrote it here in green. P of 2 is equal P of 4 equal P of 6, right? Why? Because we are saying that an even number is twice as likely to occur as an odd number. So all even numbers here, they have the same probability. All odd numbers here have the same probability. And we know that P1 equal P3 equal P5. But the idea here is that we do not know the exact value for P of 1 or the exact value for P of 2. So we give it a name, X, as a variable. And our name is to do what? Our name is to evaluate the X, the value for X. Okay, guys. We know that P of S is equal to what, guys? Equal to 1. It means that P of this set is equal to 1. What do we mean by P of this set equal 1? It means that P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6 is equal to what? To equal 1. So let's substitute. P of 1, X. P of 2, 2x. So we're going to get X plus 2x plus X plus 2x plus X plus 2x equal to 1, right? So we will get 3x plus 6x equal 1. It means that x equal to what? X equal 1 over 9. So we got now that P of 1 equal P of 3 equal P of 5 equal 1 over 9. P of 2 equal P of 4 equal P of 6 equal 2 over 9. But our aim here is to do what? Our aim is to find P of E. And what's P of E, guys? P of E, what's E? E is the event So guys, let's check what's E. E is the event that less than 4 occurs. So what do we mean by less than 4? It means that it can be 1, it can be 2, it can be 3. Why didn't we put here 4? Because we are saying less than 4 and we are not saying less than or equal to 4. So P of 1 is 1 over 9, P of 2 is 2 over 9, P of 3 is 1 over 9, 1 plus 2 plus 1, we're going to get 4 over 9. So probability of E is equal to what, guys? It's equal to 4 over 9. Okay, guys. Here we have a rule, already we applied it before, that we are saying that if an experiment can result in any one of n different equally likely outcomes, and if exactly n of these outcomes correspond to an event A, then P of A is equal n over n. This one is exactly what we said before when we have tail and head, and we are tossing the coin twice. We want to find the probability of A that we wrote it in the beginning. We got P of A is equal to what, guys? Equal to 2 over 4, which is half. Okay, guys, let's do this exercise. Here we are saying that a statistic class for engineers consists of 25 industrial engineers, 10 mechanical engineering students, 10 electrical, and 8 civil engineering students. We are saying here if a student is randomly selected by the instructor to answer a question, find the probability that the student chosen is an industrial engineering, and in part D, civil or an electrical engineering. So guys, let's find first the total number of students. So we have here 25 industrial plus 10 mechanical plus 10 electrical plus 8 civil engineering. So the total number of students in this statistic class is 53. So we need this person or this student to be industrial engineering. The number of industrial engineering is how much, guys? It is 25. The total number of students is 53. So we're going to get 25 out of 53. This will be the probability that this person to be chosen is an industrial engineering student. Then we are asked civil or an electrical engineering. Now, civil or an electrical engineering, let's go back to the civil. The civil, how many do we have? We have 8. Electrical, we have 10. So, P of C union E is 8 plus 10 over the total number. It will be 18 out of 53. Okay, guys, here we are sharing some rules. If we have two events, P of A union B, it will be P of A plus P of B minus P of A inter B. Guys, if A inter B is phi, or we can say A and B are disjoint. So when we say disjoint or A inter B equal phi, we're going to get P of phi. So let's put it here as a note. P of phi. Phi, it means that it's the empty set. P of phi is equal to what, guys? It's equal to 0. So if we substitute in this formula, we're going to get PA plus P of B minus 0, which is in this way. Why? Because A and B here, we are saying that they are disjoint events. Now, in part 3, here if we have more than one event and all of them are exclusive, mutually exclusive, it means that each two of them, their intersection is phi. So just we're going to add the probability of each of them. Okay, guys, let's solve an exercise now. Here we are saying what's the probability that a total of 7 or 11 is obtained when a fair dice is tossed. When we say fair dice is tossed, it means that what? It means that all faces, they are what? They have the same probability. So we have 6 faces in a die. We have 6 faces. So each face, it has the same probability, which is 1 over 6. By the way, guys, here we have 2 fair dices, okay? 2 fair dice. It means that we are tossing 2 dices. Okay, guys, we are saying A is the event. We need the total to be 7 or 11. So when can we say that the total is 7? We're going to name it as event A. When the total is 11, we're going to name it as event B. So P of A union B is P of A plus P of B. Why didn't we put A into B? Because it's impossible that the sum of 2 numbers to be 7 and to be what? 11 at the same time. So the intersection between these 2 events is what? Is phi. So we're going to use this one. P of A union B is P of A plus P of B. So guys, when is it 7? If we have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Do we have other options? Of course not. Now, P1 and 6, it means that probability, we need the first one to be what? The first one to be 1, the second one to be 6. So it's probability 1 over 6 times 1 over 6. 2 and 5, it means that the first die we got phase 2, which is 1 over 6, probability of it. The second die we got 5, which has probability 1 over 6, and we're going to continue so on. Now, probability of B, it means that the sum of the two numbers, it should be what? 11. So to be 11, we have only 2 options, 5 and 6, 6 and 5. Do we have other options, guys? If we want to choose 4 plus what we're going to get 11, we need 4 plus 7. Do we have a die that has a face numbered as 7? No. Only the faces of the die, they are from 1 till 6. So here the same, to get 5, 1 over 6, to get 6, 1 over 6, and so on, we're going to get 1 over 18. Then we're going to substitute P of A union B is 1 over 6 plus 1 over 18, which is 2 over 1. Okay, guys, let's solve some exercises from the book. Here we are saying that the probability that an American industry will locate in China is 0.7. The probability that it will locate in India is 0.4. And the probability that it will locate in either China or India or both is 0.8. Guys, please pay attention to this one. When we say either X or Y, it means that we are using what here? Union. When we say in both, it means that we are using what? We are using intersection. Here we are saying what's the probability that the industry will locate in both countries. So here what do we need, guys? We need their intersection. So guys, first we're gonna name our events. We're gonna say, let's see the event that the company will get. We're gonna be located in China. I will be the event such that the company, will gonna be located in India. So P of C union A is P of C plus P of I minus P of C into A, right? We have P of C into union A. It's what? It's 0.8. So guys, P of C union A is 0.8. And P of I is 0.4 and P of C is 0.7. Let's substitute. So we're going to get 0.8 is equal 0.7 plus 0.4 minus this one. This one is the unknown here. So bring it to the other side. We're going to get 0.7 plus 0.4 minus 0.8, which is 0.3. Okay, guys. We need this one to be occurring in neither cities. Neither cities, it means that it's not in C. Not in C, it means that we put C bar. And it's not in I. Because India, we put it as I here. We named our event as I. So let's write it. So we need it not in C, not in China, and also we need it not to be in India. So we need to find probability of C bar intersection I bar. Now this one, guys, according to De Morgan law, those who took discrete mathematics know what we mean by De Morgan law, but even if you did not take before discrete mathematics, we're going to write the rule here. This one is equal C union I. So the intersection becomes union. And what do we put here? Bar. When we say C bar, it means that not C. When we say I bar, it means that not I. So we need not C and not I. Okay, guys. So we need the probability of C bar inter I bar, which is the probability of C union I, all of it bar. But guys, when we say P of X bar, P of not X, guys, if the probability that your instructor will gonna give you a class is 0.1. What will be the probability that your instructor will not gonna give you a class? It will be 1 minus 0.9. So if you have a chance to have a lecture with your instructor is 90%, then the chance not to have a lecture, it will be what? It will be the remaining, which is 10%. So P of X bar is 1 minus P of what? P of X. Okay, guys, great. Let's use these two ones. So this one is P of C union I bar. Then it will be 1 minus P of C union I. P of C union I already it was given at 0.8, so we're going to get it as 0.2. Okay, guys, let's proceed right now. Okay, let's solve some exercises. Now, guys, here we are saying in a poker hand consisting of 5 cards, find the probability of holding 2 aces and 3 jacks. Guys, in this course, we have to know in a poker hand how many elements do we have, which is 52. If any of you plays cards, you know that the card we have 52 cards. Okay, guys. And we have to know that what do we mean by tossing a coin. Okay, guys, let's solve this exercise together. Again, how many cards do we have? 52. We are taking from them 5. Now, why did we use here combination and we did not use permutation, or we did not use we did not multiply 52 by itself 5 times? First, we did not multiply 52 by itself 5 times because here it's without repetition. What do you mean by without repetition? It means that if we are taking 5 cards, these 5 cards, it's impossible in a normal poker hand to have the 5 cards, let's say all of them, they are jack and they are heart and jack at the same time, right? Also, guys, if these 5 cards, we are saying that they are jack, queen, king, ace, and number 2, or we are saying that they are ace, 2, jack, queen, and king, both of them are the same. It means that the order is not important here. So the order is not important. Repetition doesn't exist here. So what do we have? Combination. 52, 5 from out of 52, the combination is 52 factorial over, sorry guys, this is 5 factorial. Let's fix it. So 52 factorial over 5 factorial, 52 minus 5, which is 47 factorial, and we're going to get the answer here. Here we have 5 times 4 times 3 times 2. We're going to get the answer in this way. So that, guys, n is the number of ways to get 2 aces and 3 jacks, right? Because we are asking about the probability for holding 2 aces and 3 jacks. Now we know all that we have in a poker hand, in a normal one, we have 4 aces. So we need to take 2 out of 4 aces. And we know also that we have 4 jacks, so we need to take 3 out of 4 jacks. So evaluating this one, 4 factorial over 4 minus 2 factorial times 2 factorial, and this one, 4 factorial over 3 factorial, 4 minus 3 factorial, we're going to get the answer as 24. So according to our rule, the probability it will be 24 out of this one, which is 0.9 times 10 power minus 5. Guys, the answer is logical. Why? Because if we are distributing the card and we need to take 5 cards from it, the possibility to get 2 aces and 3 jacks at the same time is very low, right? Okay, guys. Here we have another exercise. We are saying that Sam is applying for 2 posts, full professor and head of the research committee. His probability of getting full professor is 0.8, and that of being a head of the research committee is 0.6. Now, Sam believes that his probability of getting the 2 posts is 0.5. It means that if we are naming the full professor as the event F, so P of F is 0.8. And this one, if we are naming it as H, we're going to get P of H equals 0.6. He believes that his probability of getting both of them, it means that this one is P of H enter F. It will be 0.5. Now we are asked, what is the probability that he will get at least one of the posts? When we say at least, it means that union. So what do we need here exactly? We need H union F. Then we are asking, what's the probability that he will take neither post? Neither post, it means that he will not take the post of full professor and he will not take the post of what? Of the head of the committee. So guys, we said that let F be the event full professor, H be the event he's gonna be a head of the committee. P of F is 0.8, P of H equals 0.6, P of F into H is 0.5. These ones are what are from the given. Now, at least one of F and H it means F union H. P of F union H is, according to our rule, P of F plus P of H minus P of F into H. So 0.8 plus 0.6 minus 0.5, which is 0.9. In the second one, we need not F and not H. He will get neither of them. So it's P of F union H bar, just we wrote the formula. Let's go back to it. This is the formula for it. And the bar here, or not, it will be 1 minus P of F inter H, so it will be 0.1. Now in part C, what's the probability that Sam will not get at least one post? So what do we need here? Not F or not H, which is F inter H bar, so it will be 1 minus P of F inter H, which is 1 minus 0.5 equal to 0.5. Okay guys, by this exercise we are done for today's lecture.